My name is Shriya. I work at IBM in Ceph storage team, and I have total 7 years of experience with software-defined storage technologies. And today we'll be discussing about how we can formulate our open storage strategies for Kubernetes. So let me start by asking you all a question. What is that one thing that no one really talks about until it fails? Storage. Yeah, of course. The answer has to be storage for this particular talk because then it won't make sense, right? It would be very weird if I said networking or something like that. But just to highlight this point, that if we misconfigure any other component of Kubernetes, our application would still be partially operational, right? But if we misconfigure storage, or if our storage totally, like the service totally goes down, it will totally take the application down, and you will see you will see your application won't be working basically. So yeah, that's right. It's storage. To understand this better, let's take an example of our friend John here. He has e-commerce startup, and everything is running on Kubernetes. When he was building this platform, he didn't really focus too much on storage because he's like, okay, let's use whatever, and it runs. Like everything is working fine. Like all the customers are using this platform. His business is booming. Everything's working well, until one Black Friday he decides to host a sale, and yeah, demand definitely increases for his application. And that this is when the trouble begins, because during this Black Friday sale, his storage goes down. Now, because of this, all of the checkouts are failing, carts are abandoned, transactions are failing, customers are angry, they can't shop anymore. So this type of situations can arise if your storage is, of course, not configured properly as per your workload. So this is a reality for many setups, because since the storage is not misconfigured, or it's not really well thought out, when it breaks, your application breaks, and you lose a lot of revenue. So for small startups like this, it can mean the difference between growth or shutting down. So this means our storage is really one of the most crucial elements of your Kubernetes environment. So luckily, John discovers the smarter storage for Kubernetes that is customized for his application needs. It's simple, it's reliable, it's cost efficient. Now he can focus on his business, and he won't be firefighting outages anymore. So that's what we will be basically discussing today. We'll be discussing the strategies that we can implement so that our storage is more reliable, and it's also cost efficient. And again, it is supporting your Kubernetes application demands as well. So yeah, the question here is why does the storage matter so much in Kubernetes, right? Just like we discussed earlier, our Kubernetes workload is dynamic, and our requirements for the storage are also very, very dynamic. Our storage does not only need to be reliable; it also needs to be able to scale along with your applications and along with the demands of your workload. So a sudden surge of data or like some unexpected failure should not affect your storage. So by default, as we all know, the Kubernetes applications are stateless. So when you restart the pod, your whatever progress you are doing with your data on those particular pods, when it goes down, when the pod restarts, your progress is gone. So without the reliable storage, you won't be able to achieve most of your, whatever, most of your applications requirements, right? So when we think about traditional storage, this is not really designed for Kubernetes workloads because they are usually sold as an appliance. So it means that your hardware part and software part is coupled together and sold as a box, which again is it leads to a vendor lock-in situation where in case you want to scale up your storage, you have to spend a lot more money than you would in case of software-defined storage. So the challenges here are capacity, scalability, and cost. Like, think of it as a fridge, right? Your traditional storage, when you when you buy a fridge, right? When you run out of space, you have to buy another fridge instead of just adding another shelf in the fridge. So yeah, again, it kind of leads to a single point of failure type of situation. So also, it was never designed for cloud native applications. So the applications are very dynamic and they are very flexible. And this traditional storage cannot really keep up with the current application demands. So this is where your open source storage comes into picture. So we have software-defined storage here. So software-defined storage, as the name suggests, it is your storage layer separated from your hardware layer. So your storage layer will run on your commodity servers, and it will use commodity hardware. So this eliminates the vendor lock-in situation, because now you can just use whatever vendor. You can mix and match different vendors. As per your budget as well, you can just add one or more hardware and different vendors from different vendors. Also, since open source storage is community-driven innovation, it is more up to date with the current Kubernetes updates, and it has community support. So it again helps us with the fast-moving Kubernetes needs. Again, since it can run on commodity servers, it's not as expensive as your traditional storage, which runs on proprietary hardware. Some of the examples are here. We'll be discussing this examples further. Like, we have Rook-Ceph, we have NooBaa, OpenEBS, Longhorn, etc. So with that being said, Kubernetes storage also, it comes with its own challenges. As we all know, persistent data cannot move around like containers. Like our Kubernetes workload is very flexible. You can move our pods around in different zones, in different hosts. We can scale them up as needed. But that doesn't always happen with the data, because we have to make sure that the data is consistent, right? The most important thing here with the storage is that we want to make sure that our data is consistent and it is reliable. Also, different applications have different performance needs. So for database applications that are running database, they require low latency performance throughput versus something like archival, which does not necessarily need low latency. Also, there is no one-size-fits-all. For different workloads, we require different storage types. So your storage type can be file, block, or object. So for different workloads, certain workloads work better with, let's say, block, while the others work better with the file. So you also need to plan this beforehand. Also, storage architecture flexibility is a issue. Like I mentioned earlier, Kubernetes workloads are quite flexible, but as compared to that, when we think about storage architectures, we have to plan a lot of things beforehand. So if we skip that thing, or if we are just not clear at the start stage of your architecture deployment planning, this can cause a lot of issue. Again, reliability versus cost is always a trade-off. Sometimes we have to pick one over the other, depending on the situation. So how we can choose better, storage here. So these are some strategies that you would need to consider before you even, look at a particular storage, right? Storage platform. So you need to make sure that whatever storage platform or storage project that you are planning on selecting, first and foremost requirement is that is it reliable? What type of, what level of reliability can it provide? Right, and then the second is scalability. Can your storage grow as your data grows? Is how easily is it scalable? The third is flexibility. So the support for block, file, object, storage type, can it give you that sort of flexibility to move your storage around in these three storage types? Then is it able to integrate with Kubernetes? Like this is very obvious. Like you want to make sure that if you want to have a storage deployed for your Kubernetes applications, it should be compatible with Kubernetes. So generally we have CSI drivers for most popular storage projects that are out there. Again, cost efficiency, is it cost efficient? Can it run on commodity hardware to avoid the vendor lock-in, which is, again, really important when you want to avoid hefty prices. If your storage is able to tick all these boxes, then you're in a good position. So how do you actually choose? So these are some general guidelines for choosing the storage. So you can start with the first and foremost thing you need to do is to understand the workload. You need to know, maybe you need to have some meetings with your application teams and understand what type of workload you will be using. So this is very generic, thing that we see. So mostly for databases, we use block. Because it gives you better performance and it gives like a low latency. For shared files or ML workloads or even like some file hosting websites, we use file storage type. For backups and cloud native apps, object storage is generally used. So if you want, the second one is you need to check the Kubernetes integration, like does it have its own CSI drivers? Does it come with operators? And a lot of teams have this requirement for snapshots so that you can roll back in case something happens with your, if it gets corrupted or something, you can roll back to the previous version. So snapshots are a good feature to have in your storage platform. So yeah, make sure what type of requirements that you may have in the future. So snapshots or clones and stuff like that, if that particular project can provide that. And the third one is balancing reliability versus the cost. Not every workload needs to have same level of redundancy, so you can determine which are mission critical applications versus which are just like, let's say, archival applications. Or for example, if you have like dashboard that is collecting a lot of data and saving it somewhere, that does not necessarily need to have a lot of redundancy. Or maybe you can have a policy where it removes the metric data after like 1 hour or 1 month or 2 months, stuff like that. So in that way you can try to save some cost. And finally, look at the community. Is it even active? Is that project active? Is it supported? Is it widely used? So if it's widely used, then you can look at the use cases that other companies or other people are using it for, and see if it matches your use case as well. So this is important if you are not really fully aware, or if you haven't dipped your toes into this. So it will help you it will help you with the it will help you with the ecosystem that you will be building around. So this we just discussed earlier. So storage types, this is the, whenever you write your data, it will be stored in these three forms. It can be either stored as object storage, file storage, or block storage. So when we say block storage, you can think like a virtual hard drive. So this is best for databases or like a VM storage situations. So some of the examples for block storage is Ceph RBD, Longhorn. Some for file storage, think of it as a shared folder. So it is best for ML workloads, data sets, legacy apps, or even like websites and stuff. Also, object storage, you can think of it as a bucket of data. So most of the times we use it for media files, backups, logs. That also works well with the object storage. So these are some popular projects that are out there. We have Rook-Ceph, NooBaa, Longhorn, OpenABS. So this is not to say that one project is better than the other, or like this is the best one, like pick this one. So it really depends on your requirement, like whatever applications that you are using, and also what type of workload that you are planning on deploying. So let's say Rook-Ceph. For Rook-Ceph, it's best for if you have like mixed workload and if you have like large clusters, because it's highly scalable. So it is if you're not really sure, like, okay, I don't know what type of workloads we are going to be having. We do have block, we do have file, but I'm not really sure if we will be using object or not. In that case, you can just deploy Rook-Ceph because it gives you all these storage types. Then you can scale it as you go. With NooBaa, if you have like multi-cloud environment and you will be using object storage, your application is mostly object storage heavy, then you can use NooBaa. With Longhorn and OpenEBS, they are very lightweight block storage. So think of it as good. The Longhorn is good for edge and SMB workloads. It is easier to deploy, and it's more lightweight as compared to Rook-Ceph. OpenEBS is a per pod storage. So in case you have like if you have a requirement that you want like really, really low latency workloads, in that situation, you can use OpenEBS because the storage is per pod instead of it going through lots of layers. As compared to Rook-Ceph, it will go directly back to your storage backend. So this is just a decision diagram to determine what is like, depending on workload, what type of storage you should use. This is just very generic. So these are some smart features that Kubernetes storage provides. So we have dynamic provisioning here. With dynamic provisioning, whenever you request a PVC, the volume is created automatically in the backend. This eliminates a lot of manual work. We also have snapshots and clone features. So snapshot is a point-in-time recovery. So let's say I take snapshot at 1 p.m. I do some corruption in my particular volume, and I want to roll back to that 1 p.m. snapshot. I can just do that. And we also have scaling, so we can scale volumes without any downtime. So a lot of times our applications may just get a surge of data, or like any due to whatever unknown reason, if you want to scale it up, then you can do that. We also have operators so that we can automate a lot of tasks. So operators basically have whatever mundane admin tasks that we do, the operators automate it so that we don't have to do those tasks again and again. So these are just features that make open source storage usable in a real production environment. So this is the tricky part. We want to balance reliability versus cost. This is a dilemma, really. So if you want high reliability, you would end up having to pay higher cost. If you want to have higher reliability, you would ideally replicate your data 3 times, and you could have those replication, spread across multiple zones, and your backend storage would be premium SSD. So for that, again, you will be paying higher cost. And if you want to go for cost optimization, then you would go for fewer replicas, single zone storage, and cheaper HDDs, which again, it's very risky because it could give you low performance or it could be vulnerable to outages. So the balancing act here is to use replication for your mission critical applications versus we also have this erasure coding facility. So you can use that to, it uses less storage, but it can use more resources. So that you can use that for your slower, for your archival or applications that are not that much critical. You can also match storage to workload. So for databases, you require better, backend. So you can use SSDs for databases, and for backup and archives, you can use HDDs. And tiering also helps if you can put your hot data on faster storage and your cold data on cheaper one. So this is where a lot of times things go wrong. We can make a lot of configuration mistakes. So these are very generic one that I have seen over the years. A lot of times misconfiguration of replication can risk data loss, because if you have like a mission critical application and you haven't replicated it enough times, then you will lose data. Bad failure domains, like if you have your cluster deployed on just one zone or one rack, your whole system is at risk when that failure domain fails. And not accounting for replication and sizing. So if you're replicating your application 3 times, you have to make sure that, okay, if I know that 10 TB will be the storage size, or the data that will be stored in my system, it will, in the backend, it will be replicated 3 times. So actually you will need 30 terabytes of data in the backend. Also cost pitfalls. If you over provision a lot without monitoring, you will get surprised cloud bills. Also, if you thin provision without monitoring, you will just suddenly run out of space, and you won't be able to figure out okay, why is it running out? Because with thin provisioning, the issue is that you will see that you have some storage when you look at it from the machine, but in the backend you actually don't have any space. So using high performance storage where it's not needed, again, it kind of increases unnecessary costs. The third is design pitfalls. Is when you are planning your app architecture and you ignore storage in that phase, you will end up having bottlenecks later. Workload storage mismatch. If you are running database on file storage or object storage, it will give you really bad performance. Then that again causes issues. And if you're not planning for capacity, if you don't know when you will be having a surge of data, it's better to get an idea if you will be having a surge of data beforehand, so that you can scale it, right? Also, ignoring network impact. You should ideally keep your storage traffic on a separate network than your actual data traffic. That's ideal. Another is operations mistakes. This is, in your planning phase, you need to make sure that you are, testing your storage for backup and DR. So even if you follow all the rules and you set up your storage the right way, you will someday you will have a disaster. Like that is definitely going to happen because no system is perfect. So you need to plan for it beforehand. So yeah, definitely it's better to have a backup a strategy, and you need to make sure to have a disaster recovery setup somewhere. Again, skipping failure simulation, so you can just simulate this type of failures beforehand, so that when it actually happens, you're not surprised or you're not nervous about it. And the last one is really important when you have like performance, a workload that requires a great performance, is skipping performance benchmarking. So your storage, every storage has its own limitations, right? So when you do performance benchmarking, you are basically testing the maximum and minimum capacity of your particular storage that you're using. So when an ask comes, and it will come someday, that your application has some requirements that might be unreasonable for whatever storage backend that you're using, you will have some answers, right? Okay, this is the minimum that this storage can give, and maximum this storage can give. So you'll have those numbers handy when that situation arises. And these are the popular open source solutions, like we discussed. With Ceph with Rook, it gives you file, block, and object storage. This is proven to be production grade. It has a lot of community support. We have NooBaa, which is cloud native object storage. It's generally used in multi-cloud setups so that you can move your data across different clouds. We have OpenEBS. It is easy local storage for Kubernetes. It's per pod storage. And we have Longhorn, which is, again, block. It gives you block storage. It's lightweight, and it's great for edge applications. So these are some best practices. So we have, you should select the storage based on the workload requirements, like we discussed. So each storage type performs, it will give you different performance for different workloads. So you need to make sure that you're choosing the right one. Consider the tiering. If you can do that, that will be, again, it will be cost efficient. Look at the flexibility in the storage platforms, because again, if you're not very clear in the get-go what type of workloads you will be deploying, a lot of times we have like huge clusters that have like different types of applications. In that case, it's better to choose a platform that gives you all the storage types. Keep prod and test clusters separated for obvious reasons. You don't want to test something on production and break it. Test performance benchmarking, failure and recovery before going live. Again, it better prepares you for the disaster. And yeah, you can learn from community docs and upstream for best practices, and maybe you can discuss whatever issues that you're having with your peers and get some insights. So here are some key takeaways. So first thing to understand is that your storage is very critical. When it breaks, your application will break. It will cause havoc. Open source storage is reliable and cost effective when you use it wisely. You should know your workload first before even going and choosing the right solution for yourself. When you choose the right solution, you need to monitor, test, and right size to avoid any surprises. And yeah, we can connect over LinkedIn. I'm available on LinkedIn, and I'm over here to take your questions. Any questions? No? Thank you.